Okay, so P10.6 impact forces, and what we're going to look at now is we're going to look at how much force does it take to change something's momentum, and what factors is that affected by. Okay, so let's give the example of a car. And if you imagine that you're in a car and you have a crash, well, one of the things that happens when you have a crash is that this bit crunches up, and that's called the crumple zone. But why does it do that? What is the point in having a car that deliberately crushes easily? When you see some wreckages, the cars look horrendous, but they're designed to do that. They're designed to give, whereas previously they weren't designed to give. They'd have a crash and they'd look very similar to how they were before the crash, but the problem then is, well, you'll see what the problem is going to be in a minute. Okay, and the other example I want to talk to you about is a cricketer. And if you imagine a cricketer catching a ball, what they do is when they catch the ball, they move their hands down in order to take the ball. So both these two examples are doing something with the amount of time that the impact lasts for. And what they're doing is they're increasing the amount of time that the impact lasts for. So if we have a think about this, we want to go, okay, so I want to stop something. So in order to stop it, I know I've got to make its momentum 0. So that means that I've got to change the momentum. So this is going to be, so I'm going to need to change the momentum. So how much? So I'm going to need to apply some force to change the momentum, and the more momentum I have, the more force I'm going to have. So I know that they're going to be proportional, and it's going to be linear. So I'm going to say that force is proportional to changing momentum. Okay. Now, what determines how proportional it is? Okay. What is it that? What can I use? So if I remember what we said, we can use F equals, and I'm going to use a symbol for change. So the symbol for change is a triangle, and that's delta. I can't remember if I've used that before, but change means delta. So I'm going to say that F equals delta mv, which is the change in momentum. And this one's on your equation sheet. And the brilliance of this one being on your data sheet is there's a little bit of a cheat, because it says that force is equal to change in momentum divided by time. And if you know that, and it also gives you the symbol, so it says change in momentum is delta mv. Well, that's a nice clue to what momentum is. Should you forget what momentum is? Well, you know that change in momentum is change in mass times velocity, so momentum is just mass times velocity. So you get 2 equations for the price of 1 on your data sheet there. Okay, so, and I want to turn that, and remember we've said that if you want to turn a proportional into an equals in physics, you want to times it by a constant. So that's going to be times some constant, or some factor. So I'm going to say F equals delta mv. And the factor that I'm interested in is time, because what we've said is these two both manage to reduce the force by increasing the time. So if the force decreases as time increases, well, we say that they're inversely proportional. And if something's inversely proportional, we pop it on the bottom, not the top. I put time there. Okay, so what I'm saying here is the more I want to change the momentum by, the more force I will need. But the longer I take to change that momentum, the bigger this number is, the smaller this number is. And that's why cars have crumple zones. It's why cricketers move their hands backwards in order to take a catch. Okay, so let's give an example of that. Let's give the example of a bullet hitting a bulletproof vest. Okay, and the bullet has a velocity of 10,000 meters per second and a mass of 0.01 kilograms. Okay, and we want to, and let's say that it is stopped. It takes 2 seconds for the bullet to be stopped by the vest. Okay, So I'm going to say that T equals 2. What I want to know is what is the force, so F equals question mark. Okay, so that means that F is going to equal 10,000 times 0.01 all divided by 2. So I'm going to say that 10,000 times by 0.01, well, I can cancel out my zeros just like I did previously. So 0.1 would knock off 1 0, 0.01 knocks out 2 zeros. So that gets rid of my zeros. So that means it's going to be 50 newtons. Okay, and if you think that somebody standing on you is a force of about 1,000 newtons, then you can see that that could stop that. Now, I exaggerated this by saying it takes 2 seconds to stop it. It would probably take 0.2 seconds to stop it, or 0.02 seconds to stop it, at which point you've got 500 newtons or 5,000 newtons. Okay, so the longer it takes to stop it, it makes a big difference to how much force is going to be applied. And just make sure you remember this equation here, and that this delta, this triangle, means change, and that is on your data sheet. And all it means is rate of change of momentum is equal to the force.